ChatGerry, seeing disease in 3 dimensions, why time, space, and frequency matter. Number 1519, BPT076, January 31, 2026. Gerald C. EclaireMD Foundation. Category: Research Methodology. Preface: Over the past 17 years, I have read about 10,000 medical papers. I did not read them to follow academic trends or collect citations. I read them to answer a simple question: how do chronic diseases actually develop inside a real human body? I wanted to understand obesity, type 2 diabetes, and the major mortality diseases they often lead to, such as heart disease, kidney disease, stroke, and dementia. I wanted to know how they begin, how they grow, how they sometimes reverse, and how they eventually fail. After reading so many studies, one conclusion became unavoidable. Very few medical papers study disease as a continuous process with clear cause and effect. Most rely on group averages measured over short periods of time. Even studies called longitudinal often compare only to points, such as baseline and endpoint. From a systems perspective, this is still snapshot thinking. But disease does not behave like a snapshot, it behaves like a movie. 3 domains, 1 system. My research approach is different. I do not look at disease through a single lens. I study it simultaneously through 3 domains of time, space, and frequency. Time tells us how disease changes. Space shows how different health factors interact. Frequency reveals which signals move fast, which move slowly, and which ones carry early warning. This way of thinking is common in engineering and physics, but it is still rare in medicine. These ideas did not come from theory, they came from data. My longitudinal dataset: for more than 17 years, I have collected dense, continuous data from my own body. This dataset contains over 4 million data points across hundreds of categories. It includes glucose, blood pressure, body weight, visceral fat, lipids, sleep, exercise, food intake, and many other lifestyle and physiological variables. This is not a collection of clinic visits from many people. It is a continuous record of more than 6,000 days of my own health, compared with typical medical data. It is a movie rather than a photograph. Space and time, viscoplasticity and topology. Viscoplasticity comes from physics and engineering. It is based on stress and strain. Stress and strain define the state of a system at any moment. That is the space domain, when we track how stress and strain accumulate over time. We enter the time domain. Topology comes from mathematics. It studies shape, connectivity, and structure. Instead of stress and strain, topology looks at how variables relate to each other in space. As the system changes, its shape changes. In both frameworks, space defines the system state at a moment. Time appears when the system moves through that space. History matters because past stress limits future recovery. This is why both viscoplasticity and topology are well suited for chronic disease. Chronic disease is not fully reversible. It accumulates damage over time. VMT and TDA in practice. In my recent paper on obesity and type 2 diabetes versus diet and walking, I used 2 complementary tools, VMT and TDA. VMT measures accumulated damage. I define an output, such as BMI or average glucose, and examine how inputs like food portion, carbohydrates, and walking steps contribute stress energy. This allows me to calculate how much each factor contributes to long-term damage. By adding these energy contributions year by year, I can see when damage accelerates and when lifestyle intervention begins to work. VMT answers a simple question: how much stress has the system absorbed, and when does that stress turn into disease? TDA looks at the problem differently. Instead of measuring energy size, it watches how the system moves in space. It shows clustering, separation, and structural change. In TDA, a hole or a bridge in the data can represent a metabolic crisis or a transition into a new disease state. Health becomes a shape that can bend or break, not a flat line. My hemorrhagic stroke on June 21, 2025 is a clear example. I found a low-frequency root cause. Nearly 20 years of cerebral microvascular calcification resulted from medium-frequency diabetes and a high-frequency trigger. A sudden blood pressure spike to 175 mmHg. This is exactly how engineers analyze structural failure: long-term weakening plus a trigger. Doctors often focus only on the trigger. I focus on the structure. Frequency, the missing dimension. The frequency domain is almost completely ignored in medicine, yet it is critical. Different health signals move at different speeds. Blood pressure is a high-frequency signal. It changes minute to minute and reacts quickly to stress. Glucose is a medium-frequency signal. It responds to meals and activity. Body weight and visceral fat are low-frequency signals. They change slowly and reflect long-term structural damage. This explains an important finding in my work. Obesity pivots later than type 2 diabetes. Weight responds more slowly than glucose. This is a hysteresis effect. Structure is slower than chemistry. By studying signals from fast to slow, I can infer sequence, causality, and timing. This approach is called signal processing in engineering and technical analysis in finance. In medicine, it is the key to understanding causality, prediction, and limits of current research. Using my 17-year dataset with VMT and TDA, I can estimate which major mortality disease is most likely to occur and roughly when. This is not fortune-telling. It is system-based prediction. Most medical studies cannot do this. Because their data is sparse, time resolution is low, relationships are simplified, variability is treated as noise. Statistics is useful, but when used alone, it compresses time, space, and frequency into a single number. Disease is not a number. It is a process. Once disease is viewed as a moving system across time, space, and frequency, many accepted conclusions feel incomplete, and many unanswered questions become obvious. Conclusion: these medical research ideas are not philosophy. They come from long-term data and systems reasoning. Chronic disease does not appear suddenly. It builds through stress, compensation, loss of reserve, and failure. Snapshot thinking hides this reality. The human body is one of the most complex systems we know. Understanding it requires more than linear averages. Time, space, and frequency must all be considered together. VMT measures how much damage has accumulated. TDA shows when structure begins to fail. Together, they provide both magnitude and early warning. I believe this work can help bridge physiology and control theory. If digitized into a wearable AI system, it could move medicine from reacting to fires after they start to preventing them by monitoring heat buildup in the wires. Disclaimer: I write this paper not for fame, but to share what I have learned so others can understand health, prevent disease, and live longer, healthier lives. This content is for educational reference only and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered or republished as your own. All intellectual property rights belong to the author, Gerald C. HSU. This content is provided for educational reference only and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All intellectual property rights and copyrights for this article and its related materials belong to the author, Gerald C. HSU.